Hey everyone, today we're going to go through the process for finding the derivative of inverse functions. Now I know this can be a bit of a tricky process, but there's really kind of two key things here that are going to make this process a little bit easier, and they're kind of the key to the whole process itself. So the first thing that we need to remember, and we saw this kind of in our little investigation, the first key thing is that the derivatives or the derivative of an inverse function is the reciprocal of the derivative of the original function. So that's the first thing we have to keep in mind. Again, the derivative of an inverse function is the reciprocal of the derivative of the original function. So you'll see me kind of use this notation. I'll say the derivative of the inverse is equal to the reciprocal, so 1 over the derivative of the original. So when you see that notation, that's kind of what I'm referring to. Here's the second thing we need to remember. We know that the input of the inverse is the output of the original function. And I'm just going to say, and vice versa. So the input of the inverse is the output of the original, right? The output of the inverse then is the input of the original. And that's going to play a huge role in this. So let's look at some examples and see how these two things come together. So this problem tells me that f is the function defined by f of x equals x cubed plus 7x plus 2. Then they tell me that g of x is the inverse of x and that f of 1 equals 10, and I need to find the value of g prime of 10. Now, when I always look at this, I'm trying to figure out where my inverse is. So the first thing I notice is that g of x is f inverse of x. So g of x is my inverse, which makes sense. What I'm asked to find here is the derivative of the inverse because g is my inverse. So the first thing I set up is my reciprocal relationship. So I know that g prime is really equal to the derivative of the inverse. I know the derivative of the inverse is just 1 over the original. Now, I also have to look at this. They're asking me to find g prime of 10. So I know that this value 10 is the input of the original. Let's see if that's in the... So 10 is the input of the original. So here's what I do for myself. I set up two ordered pairs, one for the inverse and one for the original, which I know, by the way, my original function is f. So my 10 here is my input of the, not the original. G was the inverse, so this is the input of the inverse. Sorry about that. So the input of the inverse is 10. If that's the input of the inverse, it means it's the output of my original. Now, if I look here, since f was my original function, they actually then told me the input to my original is 1. This f of 1 equals 10 is giving me that input and output of my original. Now that I know that, here's what I can do. I know that g prime of 10 is equal to f inverse prime of 10, right? Because these two are my inverse. Let me make a note here. These two are my inverse functions, so they use the input of the inverse. Now, when I have 1 over my f prime is the original. So f prime uses the input from the original, so I have f prime of 1, which came from this here. So now I just have to figure out what f prime of 1 is, and I'm all set. Well, we knew f of x was this function, so my f prime of x is equal to 3x squared plus 7. So then f prime of 1 is 3 times 1 squared plus 7, which is just going to be 10. So my answer then is 1 over 10. And that is the derivative of the inverse. So notice the key here really is picking out what's your inverse function and which is your original, and then plugging in the known information. All right, let's try another one. All right, so very similar problem. I have a function defined here, f of x equals 7x cubed plus quantity natural log of x cubed. I know that actually this should be a g, so let's change this. G of x is the inverse. So again, here I'm seeing g is the inverse. And I know that f of 1 is equal to 7. They're asking me to find g prime of 7. So let's see what we know. I'm finding g prime, and I know g is the inverse. So g prime, well, from this relationship, g prime of x has to be the derivative of the inverse. So it's the derivative of the inverse, and we said we know the derivative of the inverse is the reciprocal of the derivative of the original. So f is my original function. So I'll make a note here. This is my original. Now, this problem is giving me some information. Again, I know my input to my inverse is 7. So I have 2 points. I have my inverse and my original. I know my input of the inverse is 7, which means that should be the output of my original. There we go. This, we said f is the original, so this is a point on my original function. That means the input of my original is 1. So now, when I go back here, again, g prime of 7 is equal to the derivative of the inverse at 7. But now I have the input of my original is going to be 1. So just like before, because I have a function, I know that f prime of x is going to be, let's see, 21x squared. I have to use my chain rule here, so I have plus 3 times natural log of x squared times the derivative of natural log of x is 1 over x. So when we evaluate this, f prime of 1 is going to be, let's see, 21 plus 3 times the natural log of 1 is just going to be 0, and times 1 over 1, which doesn't even matter. This is going to turn into 0. So f prime of 1 is 21. So I go back up here, and my derivative is 1 over 21. So hopefully this gives you a couple of tools for kind of working through these problems. Obviously, I know this is going to take a fair amount of practice, and that's what we'll be doing when we're back in class. All right, I'll see you then.